Okay. This is like the third time I've made this video because I keep getting interrupted by phone calls and dogs and whatever. So this is the last try. You're going to get whatever you get. I'm not going to start it back over. But we're going to try something a little bit different. I thought maybe I would try so that you could see me when I'm talking. See if that's a little bit easier to hold your attention than just kind of listening to my disembodied voice, just describing words on the screen. So I don't know. It might be weirder. It might be better. We'll see. Welcome to my living room. This is where I grade all the papers and do all the work. So I'm using a different program in combination with my iPad. So we'll see how that goes too. So let me share the notes, what I'm looking at here. So hopefully you can still see me up in the corner now while I go through some of these examples. Just because I know it's hard to listen to and watch and stay focused on a video for too terribly long, I probably won't work through every single example on here, but at least I'll go through one of everything. You can pull up other examples in the notes, or if you feel like I'm doing too many examples, go ahead and fast forward, drag through the video and get to the part that you need. Just whatever you got to do to be able to get your work done. And we'll go from there. So let's try this out. This is where we are, is logarithmic equations. It's going to be hard for me to remember to look at the camera instead of looking at the screen and then not making eye contact with you. So sorry if it gets weird. So the definition of a logarithm is basically that rewriting that we've done before. So the log base b of m is equal to c. That means that b to the c power is equal to m. And that's really the main thing that we're going to use when we solve log equations. The whole point, if you look at that first line there, is we want to be able to get one side of the equation to be just one logarithm. We have to combine everything down into one. So that means we might have to move some extra stuff, a coefficient, or maybe I'm doing adding or subtracting something after the logarithm. I'm going to have to get rid of that stuff. And then secondly, if I have multiple logarithms, we're going to have to use our expanding or more likely the condensing properties to be able to take multiple logs and combine them down into just one single logarithm. Because unless we have just one, we're not able to rewrite it. So if we look at number 12, I have the log base 2 of x minus 4 is equal to 3. And the parentheses are a real key thing to look at there, because the fact that that x minus 4 is in parentheses means that all of that is connected with the log. So the log base 2 of x minus 4, that's all one term. If those parentheses weren't there, then that means that it's only doing the log base 2 of x. And if that is the case, we would have to add 4 to both sides to get the log base 2 of x by itself before we could go anywhere else. That's just kind of a side note. So for this one, the log is already isolated and we're ready to go. So we are moving on to step 2, which is rewriting the logarithm. So this gets a little bit weird when I start writing. You might be seeing a little bit of double up in the corner, but we'll see how this works. So to rewrite this, remember the base is always the base, so the base is going to be 2. Now logs are equal to exponents, so this is going to be 3. And then the only thing I haven't used yet is the x minus 4. So if you see what we've got, that is really just a basic linear equation, because 2 to the third is 8. And all I have to do now is add 4 to both sides. So x is equal to 12. Now, if you look back up at the yellow box, the last step there, step 4, says that we need to check our solution in the original equation, because with logs, since there's restrictions on the domain, we have that potential for extraneous solutions again, unfortunately. So remember that with a logarithm, whatever you're taking the log of must be positive. So if I put 12 back in, I really only need to look here. If I do 12 minus 4, I get 8. That's positive, so we're good. And so 12 is the answer. That's it. Okay. Number 13, we have this coefficient of 3 So that's where we need to start, is by dividing by 3 on both sides. That gives me that the natural log of 2x is equal to 4. Now, when we go to rewrite this, remember that the base for a natural log is the number e. So we'll say e to the exponent, which is 4, is equal to 2x. Just like when we did the logs yesterday, we carried those natural logs all the way through until the very last step. We don't want to round until we have to. Same thing here. Since e is going to be a decimal and we're going to have to round, we'll do that at the very last step. So when I get x by itself, I know that x is equal to e to the 4th over 2. And then you can put that straight into your calculator. And we're going to get 27 point something. Let me see. I just did it. Where did it go? E to the 4th divided by 2. 27.299 is what I get approximately. It'll specify how it wants you to round, but 3 is usually good if it doesn't say. So that's that. Those are the really simple ones. Isolate the log, rewrite it in exponential form, and then do whatever you have to do to solve. Let's look at a couple where we have to use some of our log properties. So this was where I had talked about before, these log properties were going to be the most important when we got to solving equations. And so that's where this is going to come into play. So let's look at these examples. So remember, the first step was that we had to get it down to just one logarithm. And in this problem here, we have 2. This is where we have to use our condensing properties. So I'm going to go back to my writing. So what we are looking at is I have the log base 2 of x plus the log base 2 of x minus 7. Addition condenses to multiplication. Maybe you can see when we do this where we're going to end up with a quadratic to solve. So I'm going to multiply this times this, and I condense that down to one logarithm. So I have the log base 2 of x times x minus 7 equals 3. Now, I went ahead and wrote that out, but when you start to get the habit of how these are going to work, I go ahead and distribute that x before I even start. So I go straight to log base 2 of x squared minus 7x equals 3. And so you see we've got that x squared in there, which means we're very likely going to need to factor or use the quadratic formula to be able to solve. And it's possible we're going to get more than one solution. It's very likely we're going to get more than one solution. So to rewrite using our definition of a logarithm, we're going to say 2 to the 3rd is equal to x squared minus 7x. Well, 2 things. 2 to the 3rd is equal to 8. But remember that to solve a quadratic, whether by factoring or by the quadratic formula, we need it to be equal to 0. So I'm going to go ahead and subtract 8 from both sides, since that's what that is. And I get 0 equals x squared minus 7x minus 8. And so now I want to see if this is factorable. So does anything multiply to negative 8 and add to negative 7? Luckily it does. So we get negative 8 and positive 1. And since a is equal to 1 here, that means that our factors are x minus 8 and x plus 1. And that means that our possible solutions are x equals positive 8 and x equals negative 1. But now remember, we need to check. So we go back to the original, and I need to look both here and here. It's going to have to be able to work in both of those logarithms. So if I look at 8, log base 2 of 8, that's good. Log base 2 of 8 minus 7, that gives me 1. That's also good. So 8 is fine. Negative 1, I can't do the log base 2 of negative 1. So that makes negative 1 extraneous. And that means our only solution then is just 8. So x equals 8 is all that we get, okay? If it were not factorable, we'd have to use our quadratic formula. You can look that up in your notes or just Google it if you don't remember the quadratic formula. And so that's what we would get. So I'm going to go ahead and leave number 15. You can try that one and then check your notes that are posted online to see if you're on the right track. But let's go ahead and move forward. So the last little bit here, and then I'm not going to go through the word problems because usually they give you the equation and you can solve it even if it's a word problem. So using the one-to-one property for logarithms, it's kind of a different one-to-one than what we've talked about before. One-to-one has described type of functions. In this case, we're not talking about functions like on the graph. So this one-to-one, we're literally just saying there's a direct correspondence between one log and the other logarithm. That's all we're trying to say here. Uh-oh, my computer's gonna die. See if we can finish with 9% to go. So this is basically the same idea as what we did with the exponentials yesterday, where we said if I can get the same base on both sides, then the exponents have to be equal. Same thing here. If I can get both sides of the equation expressed as a single logarithm that has the same base, then we can use, if you look at number 2 up there, if the log base b of m is equal to the log base b of n, then just like yesterday, hopefully it makes sense that m and n would have to be the same thing. So let's go ahead and look at an example here. I'm going to move this up to give myself a little bit more space. So these two are a little bit different because instead of multiplying when we condense, we're going to end up dividing. So for number 16, I have the natural log of x plus 2 minus the natural log of 4x plus 3 is equal to the natural log of 1x. So first problem, I have 2 logs on the left-hand side and only 1 on the right. I need them both to just be 1. So that means I need to condense. Now, when we have subtraction, that condenses to division. And don't forget, whenever you condense, we're going from 2 logs to 1 log. So you should not have a natural log written more than 1 time. So we're going to just have the natural log of x plus 2 divided by 4x plus 3. And that is equal to the natural log of 1 over x. Well, that tells me then, based on this property, that these two quantities have to be the same. So I'm going to solve the equation x plus 2 over 4x plus 3 is equal to 1 over x. Remember that other thing I told you was never going to go away, your rational equations and expressions? Here we go. But this one is nice because it's just a over b equals c over d. We can cross multiply to solve these. So that means I'm going to multiply here and I'm going to multiply here. So the first one, 4x plus 3 times 1, well, that just gives me 4x plus 3. The second one, when I multiply by x right here, I'm going to have to distribute that. So I get x squared plus 2x. And what do you see? We got a quadratic again. So we need to get this equal to 0, try to factor it, and if not, use the quadratic formula. So I'm going to move the 4x and the plus 3 to the other side of the equation. So I will subtract 4x here, and I will subtract 3 as well. So these two in the middle are like terms. I get 0 equals x squared minus 2x minus 3, and we got lucky again. Sorry for the beeps. We got lucky again. This is also factorable. So I get x minus 3 and x plus 1, which means my possible solutions are positive 3 and negative 1. And now we need to go back to our logarithms and make sure that works. So we got to check x plus 2. 3 plus 2 is 5. That's good. 4 times 3 plus 3, that's positive. And 1 over 3, that's positive. So 3's in. Negative 1 is not going to work. It'll work on the left-hand side. Negative 1 plus 2, that's positive. But here, negative 4 plus 3, not going to work. So negative 1 is out. So that means our only solution is positive 3. And so that's where we go from there. The number 17 is exactly the same. Once again, feel free to look that up in the notes to see some extra examples. So that's really it. That's the end of chapter 3. Did my video just go away? Oh, sorry, that's awkward. You can still see me. That is the end of chapter 3. So you have 3.4 part 1 and 3.4 part 2. Those both freeze on, I believe, Monday night. And we're off school Monday. So you have all weekend to get that finished. Then you have the quiz that closes on Friday night. The weather's supposed to be bad Friday night anyway, so stay home and take your quiz. And then our test is on Tuesday. Friday, during the school day, will be a work day. So you can use that time to finish up 3.4, 1 and 2, or to take your quiz. Make sure you've got at least a half an hour to take your quiz. It probably won't take you that long, but just to be on the safe side. If you start it and don't finish it, then you've just blown one of your attempts. So that's really it. I will be back for you guys on Tuesday. Hopefully we don't get iced out. But Tuesday and Wednesday are review days. So anything you've got questions on here, come in ready with those. And actually, I'm going to go ahead now and change the freeze date to Tuesday night for both of these assignments, because I want to make sure that we can go over questions before you have to turn it in. So Tuesday night at midnight is when 3/4s will both freeze, but the quiz will still be Friday. Email me if you have any questions at all, just like always. I'm going to be pretty bored tomorrow at this meeting, or today, you're watching it now. So, shoot me an email just to say hi. That's fine. So I will see you guys on Tuesday, hopefully. Be safe this weekend, and I will talk to you guys later.